Now, guys, before we go on further with our deliberation on functions, I just want to bring something to your attention. And this is basically what we call conditions for a function. Okay, what are the conditions for a function? So I've got about 1, 2 here. So 1, 2, 3, 4, about 4 functions plotted here. I could actually add another one, but I just don't want to confuse you for now. I'll leave it at this. I want us to look at conditions for a function. All right, then we're going to eliminate anything that is not a function and then practice again on finding the domain and the range for whatever is a function here. I've got graphs here, but I must say not everything here is actually a function. So please follow close with me. Make sure you are not lost as we do this. All right, because your next activity after this will be to actually try and plot a function on yourself, on your own. Right, let's take this as step by step and easy as we can. So I'm going to draw a line, and this line is what I call, or we commonly know, refer to as the vertical line test. So you can see the red line. I've made it red because it's going to test for us what is a function and what is not a function. Now, let me tell you what we are looking at in this test. When we look at this test, we expect to see the following. For one x value, there must be one y value. If we're going to have two y values for one x value, then we are going to have a problem. It is not a function. However, in a function, we can have two y values corresponding to, we can have one y value corresponding to two different x values, but we cannot have one x value corresponding to two different y values. Okay, I will explain that again in another way so that you can understand it. So if we take this and we test here, you can see what I'm having here. At this point, things seem to be very fine because I've got exactly here one x value for one y value, but I now have a problem once I start to go there. What happens here is that you can now see I've got a y value there. I wasn't supposed to move that. I've got a y value corresponding with that somewhere there. And I also have a y value here, which is different, but I've got only one x value where this red line touches the x-axis. And this is one thing that makes us cut off this circle to say this circle is clearly not a function. It fails the vertical line test. Let's look at the blue line. Maybe I should take, I should get rid of the circle. Let's put it aside. Let's put it aside. We can't put this one aside, yes. So let's come to the one in cyan or light blue. You can see for one x value, I have what? One y value. At 2, there's no repetition. As I pass through, there's still no repetition. That is for the light blue function. If you look at the straight line which passes through the origin, we can see it is clearly a function. And as a matter of fact, the domain and the range are essentially the same in this case of the straight line. But when I get to the purple one, I have problems. The same problems that I had in the case of the circle. You can see here at x equals to 3, when I am having an x value, which is just 3, I have two different y values, which is one is positive, one is negative. That's a problem. So this thing is actually not a function. So let us look at a summary basically of what does it mean for something to be a function. I will try and write this in a more descriptive way so that even when you are in bed dreaming, you can think of it and you can actually make sense of what I just said right now. So in a set, given a set of ordered pairs, all right, I'm going to write down now some stuff. So given a set of ordered pairs, guys, if I've got input values here, that is X values, and I've got Y values, I must have a case whereby for any X value here, let's say 0, 1, 3, minus 4, minus 7, etc. And let's say here we have 3, 6, 9, 8, whatever the number must be, could be. But the point is, for one element here, I must have an element, a corresponding one element there. That's what we are establishing. However, it is also possible, okay? And I must make this very, very clear. It is very possible. In fact, let me also describe the blue function and this purple one. Let me show you what is happening there. This one, we can look at it maybe as the case of the straight line. What is happening in the blue line is I've got X values. Maybe I should use that color as well. That corresponds with the function. So I've got X values and I've got Y values. But what is happening here is that if I take my line, for example, at 0 and 0, there is 0, there is also 0, there is a correspondence, right? And then if I put a minus 1 here, I have a 1 there. So if I have a minus 1 here, I have a 1 there. But if I have a 1 here, I also have a 1 there. So what is happening here, I have two elements in the X domain relating to one element in the Y, which is acceptable. That is okay. The same thing with the element minus 2 and 2. They will both relate. You see here is minus 2. You can see, sorry, that is not, yeah, that is not right. Minus 2, you can see it actually corresponds with 4 there. And 2 also corresponds with a 4 there. So you can see there's 4. So these two elements correspond to that. Okay, they both correspond to this value. Now let's see what is the problem with the purple one. With the purple one, I've got X, I've got Y. And then what is happening here is, well, it seems to start off very well, such that when I have 0 for X, I've also have 0 for Y. But once I get to 1, check what happens. If I have 1 for the X value, then I have 1 for Y value, but I also have a minus 1 for the Y value. So you see, here is the 1 positive, and here is the 1 here negative. But this is for the same X value. So we've got a problem. What we want is we can have two different X values relating to one Y value. But once we have one X value relating to two different X values, we've got a problem. So this is not a function. This is a function. Now we have names for these relationships. In this case, we say we have many to one, because you've got more than one X value relating to just one, but here you have one to many. So one X value relates to many Y values, and that is why this thing is not a function. I want you to establish this, guys, right in your heads. I want this to be part of your nature. Know the kinds of relationships that are there and how we tell if one is a function or one is not a function. I hope this has been enlightening and alarming. Keep well, stay safe. Cheers.